All right, welcome back, everyone. We have 1.3 in geometry to do now. We are going to be measuring and constructing angles. So if we take a look at our learning targets for the day, when I refer back to this cover page, we have this first one here. I can relate algebra with geometry when applying the angle addition postulate. I can solve algebraic problems involving angle bisectors. And lastly, I can measure and classify angles. So we're going to do all three of those today. So those are our learning targets, and let's just get into the notes here. So our vocabulary and our examples. So an angle is a figure made up of two rays or sides that have a common endpoint called the vertex of the angle. So the first thing we want to know is our vertex. So that common point that is part of both of the rays is going to be our vertex. So we're going to call that, that's point Q. That's going to be our vertex. Now we want to name the rays that form the side. And remember, when we're naming rays, we want to start with the end point and then go to the one that keeps going on forever, the one with the arrow. So we have ray QR, and we have ray QP. Real quick question for you, side question. Are those two rays, ray QR and ray QP, are those opposite rays? Think about it, pause the video. All right, here's the answer. They are not. Okay, they do not make a 180-degree angle and go completely opposite directions. So we want to name this angle 4 different ways. So the first way is that we want to kind of connect the dots. So our angle is going to always be in the middle. That vertex point is always going to be in the middle. So if I follow the dots here, I can start at P, go down to Q, and then to R. So angle PQR, I zoomed in a little bit here for you. So remember, angle PQR means we start at P, we go down to Q, and then up to R. So that's talking about this angle, and sure enough, that's the angle we're talking about. And because this is an angle and we're starting at one point and going to the other, it doesn't matter if we go forwards or backwards. So we can also say RQP. That's a perfectly good way of saying this as well. So angle RQP. All right. Notice here that this number 1 does not have a degree symbol after it, right? It's not saying it's a 1-degree angle. So that is actually another way we can name the angle. We can just call this angle 1. And last but not least, and this is one that we got to be a little bit careful of, if there's only one angle at the vertex, we can just call it by the vertex and call it angle Q. The issue we run into is here, let me just draw a quick picture here. All right, over there. So if this is Q and I just said, hey, I'm talking about angle Q, there's so many different angles going on there that I have no idea which ones you're talking about. So in this case, you can't just say angle Q. You'd have to say angle PQR in order to describe this angle right here. So just note, if there's only one angle there, like there's only just one angle, the 2 rays, that's all we have, then you can just say angle Q. But if there's multiple angles going on, then we can't just say angle Q, and we can only use one of the first 3 methods. All right, so we want to highlight the interior of angle Q yellow. So if we're highlighting that interior yellow, and that's going to be the inside of this angle is all going to be yellow. And we want to shade the exterior of angle Q with your pencil. So if we want to shade the exterior, that's going to be everything on the outside of it. Look at this kind of magenta circle here thing. That's going to be the exterior. All right, we have 4 types of angles. You've probably heard of these before, but we'll go over them and we'll kind of talk about them a little bit. The first one is an acute angle. You might have heard it be called, ew, it's an acute little angle. And that's because it measures greater than 0 degrees and less than 90. So that we know that this interior here has to be bigger than 0 degrees and less than 90 degrees. We have a right angle, which is always exactly 90 degrees. You'll know it's a right angle because of the little box symbol that's there. One thing that's important to assume is that you don't just assume a right angle. It'll tell you it's a right angle if it needs to be. And an obtuse angle is going to be something that is bigger than 90, so it's greater than 90 degrees, but we're still not quite at a straight line yet. So it's still not 180, has to be less than 180, greater than 90. And the very last one is a straight angle. And this one's going to be exactly 180 degrees. So think of that as like a straight line is also considered a straight angle. Very few things we can actually assume in geometry, but in geometry we can assume a straight line. So if there is a line such as this, I can assume that that is actually a straight angle of 180 degrees. All right, when the directions say to classify each angle, it means we're going to say what is the type of angle that it is. So if we look at angle NMP, we're talking about this angle because we start at N, go to M, and then up to P. So this is going to be angle NMP. And we go ahead and take a guess on this one. And this one's going to be an obtuse angle. And we know that because it's greater than 90. We have the 90-degree symbol right here, and it's a little bit more than that, so it has to be obtuse. Go ahead and try the other three on your own, problems 2, 3, and 4, and see how you do. Go ahead and pause the video. All right, so let's see how we did. So QMN, once again, starting on Q, going to M, going to N. Well, that's going to be this angle right here, so that's going to be a right angle. Next one, L to M, and then to N. Well, this is a straight line here, so it's going to be a straight angle as well. And then last but not least, PML. We have P, we have M, we have L. So we're talking about this angle right here, and we are going to know that that is acute angle. Once again, we know it's less than 90 because if this part is 90, then we know it has to be less than 90 right there, so it's going to be an acute angle. If we want to look over at how we know that we know stuff and measure the angles, we can use a protractor to do that. All right, so here, if we want to measure and classify these angles, let's start with angle AOB. Once again, I start with A, I go to O, and then I go to B. And we're going to start at 0, which means we're going to start at the bottom numbers. So we're going to start at these numbers here, start at 0, work our way up to 10, 20, 30, 40, and that's where our angle hits. So this is going to be a 40-degree angle here. So 40 degrees, we'll say it's 40 degrees here. And then when we classify, a 40-degree angle is going to be an acute angle. A quick thing to note is that when we put an M in front of the angle, that means we're talking about the measurement, and that means we're looking for a number. So when you see this M is equal to, we're looking for a number there, the measurement. All right, angle BOD. So we'll start at B, go down to O, up to D. And if we look here, this one's a little bit tougher because we're not starting at 0. So the best way to do this one is just with a little bit of subtraction. So let's start, we can start on the other side this time. And let's find just this small little bit of an angle here. We're going to say that that is 15 degrees because I start at 0 and I'm exactly halfway between the 10 and the 20. And then we're going to keep going. We're going to go all the way till we get to angle B, and we're going to see, oh, that's 140 degrees. So this whole thing is 140 degrees. So if this whole part is 140, and we want to just get rid of this part right here, then we're just going to subtract those two things. So our answer for this one is going to be 140 minus 15, which is 125 degrees. An 125 degree angle makes it obtuse. All right, go ahead and try those other two on your own. Pause the video. All right, so Angle EOA, that measurement is fairly easy, right? E to O to A. Check our thing, going from 0 to 180. So 180 degrees, which makes that a straight angle. And then measurement of angle DOC. Once again, we're going to have to do some math here. So I can calculate that this part is 15 degrees. I can calculate that this whole part is 105 degrees. So then I can do that subtraction. 105 minus 15 equals 90. And then that happens to be a perfect right angle. All right, go ahead, flip the paper over, and go ahead and try all these practice problems.